This is 1.5, properties of exponents. What we'll focus today on simplifying with exponents. There are many rules in this lesson that I would recommend that you write down. The first slide is just to kind of review what does an exponential term look like. So in this box, we have a base and then a power. This is called the base. And this is called the power, or the exponent, or the index. So that's just a definition for you. Base raised to some power. The next slide are the things that I do want you to write down. These are the properties of exponents, and you do need to remember and memorize these properties. The first property is a property of multiplication. If I have two or more exponential terms and they have the same base, so base A, and they're raised to some power, m and n, what you do to combine them into one exponential term is you add their exponents together. So that's the first property. The second property is property of division. We have the same base, A, divided by another base, A, and what you do to combine them into one exponential is you subtract their exponents from each other. So it's A raised to the m minus n. The next three properties are very similar. These are called power of power rules. So if I have an exponential term raised to the power of m and then raised to the power of n, what you do to combine it into one exponential is you multiply m and n together. The next property, you have different bases. Could be two terms in this parentheses, could be three terms more. What you do is you distribute this power n into all of the pieces in the parentheses. So that you'd have a to the n times b to the n. The last property on the slide is a fraction. You have two bases, a divided by b, raised to some power n. You can again distribute the n into both a to the n divided by b to the n. So go ahead and finish writing up these properties. The next slide, more properties. This next property is called the zero power property. If I have anything raised to the zero power, it is just 1. So if I have 5 to the 0 power, it's 1. If I have x to the 0 power, it's 1. The next property is called the power of 1. If I have an exponential raised to the first power, it's just itself. So 5 to the 1 power is 5. 10 to the 1 power is 10. X to the 1 power is x. The next property is when you have a negative power. We don't want you to leave answers with negative powers. So if you see something like this, a to the negative 1, what you do is you reciprocate. So you go 1 over a to the positive n. You might also see a negative power like this. Let's say it's 1 over a to the negative n. Then you do the opposite. It's a then to the positive n power. It flips it back up. What we're going to do on the next few slides is to use these properties to simplify exponentials. So the first example we have is d squared times d to the fifth. And we want to use those properties on the last two slides. So one of the properties says if I have an exponential raised to some power with that same exponential base raised to a power, then I can add those exponents together. So I can add the 2 and the 5 together. So I get d to the 7th. The reason why, you don't need to write this down, is I have two d's here, d and d. And I'm multiplying it by 5 d's. d, 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 d. How many total d's do I have? I have 7 of them. So I can reduce it to d to the 7th. Second question, 5 to the 7th divided by 5 to the 4th. So it looks like this, 5 to the 7th divided by 5 to the 4th. Well, there's a property that says if I have the same exponential base, they're both base 5, and there's division, that I would subtract their exponents. So 7 minus 4 is 5 to the 3rd. And then we probably know now that 5 times 5 times 5 is 125. Again, I'll show you why this works. 5 to the 7th over 5 to the 4th. Earlier in this chapter, we focused on canceling fractions. So if I have 5 times 5 times 5, I have 7 of them. And then in the denominator, I have 4 of them. And if I want to cancel, I would cancel this 5 and this 5 together, this 5 and this 5 together, this 5 and this 5, and then that 5 and that 5. What do I have left? I have 5 times 5 times 5, or 5 to the 3rd, which is 125. What we want you to do is to use the properties. Use the steps that I start off with in the blue. Next example. T raised to the 3n divided by t raised to the 6n. So very similar to the last example. They're both the same base, they're both base t. So I can subtract their exponents. So t raised to the 3n minus 6n. And now I simplify that exponent. 3n minus 6n is negative 3n. Now notice what happens in this last step. We have a negative exponent. We don't want to leave any of our answers with negative exponents. So we are going to rewrite it as 1 over t, and then we're going to have it be a positive power, so positive 3n. So that would be your final answer. Example 4. N to the 4th divided by n to the 2nd, all raised to the 3rd. So n to the 4th divided by n to the t, all raised to the 3rd. This is what we call the power to the power rule. We can distribute that 3 into both pieces of the fraction. So it's n to the 4th raised to the 3rd over n to the t raised to the 3rd. So we've just distributed in. Now, to simplify that, the power to the power rule says that I can multiply my exponents. I'm going to multiply my 3 and 4. I'm going to multiply my 3 and my t. So I get n, 3 times 4 is 12, over n raised to the 3t. Next example. Another power to the power, 2xy squared, all raised to the third power. We can distribute 2 raised to the third, x raised to the third, and then y squared raised to the third. And then remember, 2 times 2 times 2 equals 8. And then x times x times x is x to the third. This last piece is the power to the power rule. That says y squared times y squared times y squared is y to the 6th. I multiply those two exponents together. So 2 times 3 is 6. Example 6, 3a times negative 4a squared to the 0. Well, this piece, anything raised to the 0 power is 1. Anything raised to the 0 power is 1. Well, then 3 times 1 is 3, and then a. So that one goes pretty fast. All right, number 7. We have 3ab raised to the 4th times 4ab raised to the negative 3. So it's a good idea to combine like pieces. So the 3 and the 4 are coefficients, and then I have an a and an a multiplied together, and then I have a b to the 4th and a b to the negative 3. Well, 3 times 4 is 12. And if you remember the next piece, a to the 1 and a to the 1, what do I do with them? I add them together. And then b to the 4th and b to the negative 3, I add those together. So 4 plus negative 3. So 12a squared still stays as it is, and then it's b, and then 4 plus a negative 3 is b to the 1.